breakout rooms. And the reason for doing this is I have some data from 11-year-olds doing a similar activity, which helps me orientate myself in terms of special needs. And what I mean by that is understanding how students are looking at the world. And I think that's quite important. It's not about what they know, it's how they're looking at the world. And I think now I have that information, it helps me come up with appropriate activities for them that are appropriate levels of challenge. There's no point giving a child in year 7 who's 6 or 7 years behind his peers kind of an activity from upper primary. You've got to fundamentally look at how they're looking at the world and give them appropriate activities. So I'll start with the blue tack. I'll just drop them in one after the other. And the idea is I put the mystery object in, you go into your breakout rooms, you just have a discussion about what surprises you. How would you explain this? Here we go. Okay, we'll put the pasta in now. I'll put the little stone in. So the blue tack is sinking into the syrup. The stone is doing the same. I'll put the tomato in. I'll put the raisin in, the piece of orzo pasta in. Oh, it's stuck on the tomato. I'll put the pencil eraser in. I'll put the cork in. Most people would get the cork correct. I'll put the sweet in. I'll turn it around. So what I'm going to do is I'm now going to have a mystery object. And I want you to predict what will happen when I put an ice cube in. Okay, 3, 2, 1. Okay, can we go into breakout rooms and just discuss and try and explain what is going on here, please? Will you let me know when everyone's back in, please?
Yep, you've got 16 seconds to go.
Okay, thank you.
That should be everybody back now.
Aye, okay, so the reason for doing that STAR activity is it's a lovely activity to do with adults, but it links to something that some data I've got from 11-year-olds. This activity is really quite challenging. I mean, the ice floating in the oil is really quite amazing because it's not what you expect and you're having to kind of imagine something you can't see. And when words like weight or how big something is don't help, you've got to kind of use the muscles in your mind. And so it's an abstract activity that you have to kind of visualize and model what actually is density. And it's not just density, it's relative density, because it's density of solid objects compared to liquids. And so I'm just going to give you, just because we can't spend too long on this, if we were together, it would be it's a lovely activity to do because you would have all actually done this in groups. But if I tell you the density of water is 1, does that help? And can you then tell me how heavy a litre of water is? You don't need to answer that. Those are just kind of questions that push the thinking even further once you kind of discussing it. So what I've got is some data from 11-year-olds, which I found very, very surprising. And it's a Piagetian activity you can do with any, if you want to try it, I'll send you the test and send you a video explaining how to do it. And it's simply an activity on floating and sinking. From 4,500 students compared to a sample from 40 from the end of the 70s in a couple of moments. But what the activity involves is it's something you do at the beginning of year 7, and it works really well in science, is you have a series of activities where you show them things and ask them to tick or cross what they think the answer is. And so this cylinder would be filled full of water in front of them and poured into here. You'd fill it up again till no more can get in, pour it into there. Fill it up here, pour it into there, fill it up, and ask them, do they all have the same amount of water in? Yes or no? And there are a whole series of questions like that. One of the questions involves this piece of plasticine, which is a cuboid. And you tell that, and you show the children that 5 centimetre cubes fit up the side. You tell them that 12 fit on the top, and you ask them to calculate its volume. Now, whether they get that right or wrong, you give them the answer. So you say this piece of plasticine, this cuboid of plasticine is 60 centimetres cubed. And what you do in front of them is you fill this 1,000 ml cylinder full of water till no more comes in. And you lower the plasticine down on a piece of string and they see the water come out. You then say to them, how much water do you think's come out? And then further questions to that are, you half fill it full of water, you lower the plasticine in and you say, oh, look, it's gone up. What's it gone up to? In front of them, you turn the cuboid of plasticine into a ball and you lower it and say, oh, it's gone up. Do you think it's gone up more or less or the same compared to when it was a cuboid? And so there's questions like that, and they get quite hard because it's got a very low floor and quite a high ceiling, and it encompasses 95% of students at the beginning of primary 6 S1. And so what I'm going to do is I'm going to show you that data from the test. And there are 2 sets of data on this presentation. You've got the data from the original sample, which are 3 bands. And then you've got the box and whisker plot from 2014, which is 4,500 students. So I do want to have a discussion about this in a moment, but I'll explain the data. So what you've got is the red line, the green line, the purple line are from the end of the 70s, when the data was first published. The box and whisker plot is from 6-7 years ago. And what you can see is the median value is now on the lower quartile. And this sample involved schools all over the country, the north of England, the Midlands, the southwest of England, and involved grammar schools, inner city schools, rural schools. Now I'm going to show you the comparison of the marks for each item compared to a black line, which is the 70s, and the coloured lines, which the test we got. I just want to draw your attention to this black line. This is the results of the plasticine activity, where you drop it in the water. In the 70s, 73% of students got that question correct. In our sample, only 50% of pupils are getting it correct. So, do you think that information is important for us as educators, that children can't conserve volume? They don't know how much water this displaces. What is this telling us about their thinking? Could you have a discussion about that in your breakout rooms for 5 minutes, please? Doing this introduction with you is to kind of explain the professional reasons that I'm using to justify what I'm doing in the classroom. It's often the things that I've struggled to get my head around, and once I've understood it, I feel I'm doing a better job for the students in the classroom. So I've had to go through quite a massive education process, and to be honest, as a secondary teacher, teaching in primary was the hardest thing I ever did. And it helped me, and I think I can now use these activities to help the students. So the idea of the testing of the students, it gives you an insight into how they're looking at the world from a Piagetian point of view. Are they looking at the world in an abstract way where they can apply ideas from one context to another, or are they looking at it in a very simple, concrete way, one-to-one correspondence? And that's often the way that the politicians and newspapers explain things. It's simple one-to-one correspondence, but that's not the way the world works. And so saying we've got 1 million unemployed, we've got 1 million immigrants that are taking our jobs, saying we're going to build a wall to stop immigrants is a very simplistic way of looking at the world. And as soon as you get into the secondary classroom, the world isn't simplistic, it's complex. They have to juggle things in their mind. And so that for me, I'm kind of a view now of our children, simple concrete thinkers, or are they moving beyond that? But however they are, my view is that if you give them an appropriate challenge, it will cause them to talk. And so for special needs students in end of primary, beginning of secondary, we're talking about appropriate challenge that will cause them to talk. And once they talk to you and a peer, we have a chance to change their mind. You've also got this whole idea of language and metacognition and scaffolding, which comes from Vygotsky, whose two famous books are Thought and Language, Mind and Society. You've got zone of proximal development, i.e. we can all do with a little help from someone more expert, is that thinking happens between people and then it happens within. So you need, for me, what that means is you need to see your thoughts so you know what you're thinking and others can comment upon that. And then inner speech comes later. And also the idea of instruction should aim at just beyond the children, what is just ripening. And if we have very poor children, how do we know what they can do? And so the activities I'm going to share with you in a moment are aimed at very, very low-level concrete thinkers at the beginning of secondary school. They work well with 6 and 7-year-olds, and often that's the way that these children are thinking when they're struggling at age 11. And so just to pick this up, I heard someone called Les Staves speak, and Les Staves used to be a head teacher of a special school, and he really has some lovely ideas, and he's got, I can't remember the name of his website, but it's called Les Staves. And these are all things he said about working with special needs children. Mathematics is a tool of practical activity. You need to interact with it. We need to communicate. We need to develop ideas, enjoyment and engagement. What's interesting is there's a book by a guy called Stanislav Dehaene, who's a French neuroscientist, who I've just read his book, and he's talking about how we learn. One of the things he's talking about is mirth. Mirth, humor, is a uniquely human experience, and actually it can prompt engagement, attention, and can support learning. And one of the things Les Staves went on to say is maths doesn't just start with counting. We need to get at what's underpinning their structures. And so I'm going to go to an activity now that I think really works well with children who are very, very weak at the beginning of secondary school. Just a little bit about metacognition, thinking about your thinking. That's hard because how can you think about your thinking when you're thinking? But these are prompts that I use to encourage people to reflect. It's like starters to describe the thinking. And I think this works well. It's from a colleague called Stuart who first developed it. But I often put this on the wall or on the board, or the children have a card in front of them, and I'll say something red, say something blue, say something green. And if you do that with the whole class, you're slowly building an oral classroom where children can communicate their thinking. So now to the activities. All of these activities, and the ones I'll talk about later today, the CAME activities, have a kind of 3-step pattern. The first step, or the first episode, and for a lot of children that we're talking about in this session won't get beyond the first episode, you're talking about handling a context. It's real, it's concrete. It's very, very real for the children. It's often diagrams, pictorial is abstract. So interesting, in England, the concrete pictorial abstract. Pictorial can be abstract. So I would prefer to have this kind of model, which is the children work within a context. And I'll explain one of the activities in a moment. The next step is that's a bit higher, is they work with it, handling the relationships between the things in the context. So you mathematize it. And then the final step is very abstract, and the second activity I look at, I'll show how it can go to the third step, which is you leave the physical behind, and they have to do it in their mind. So we're going to look at 3 activities. One called Broken Rulers, one called Giant's Palace, one called Jelly Babies, that I've used extensively with children at the end of primary, beginning of secondary, in special schools, in pupil referral units, with nurture groups. They work very, very well if you use it to respond to the children. So I'll just give you a minute to read that, because one of the areas of focus with the activities that we use is measurement. And Nunes and Bryant, in a book called Children Doing Mathematics, make a case for children can profit from measuring in unusual circumstances, because the measurement system isn't the same as the counting system. And if all they've done is count, understanding zero and fractions and ratio and scale and proportion are really quite difficult. But if you start with measuring, you can bring them in meaningfully. So here's the first activity. I'm going to share my camera. I'm going to stop sharing and go to my camera. I would have given you these if we'd been together, but I can't. But if you need some, I will share them with you when my friend goes back to school and we can make some more. So what you get the children to do is you give them a strip with 4 holes in, and you ask them to, and you show them how to do it, and they have a bit of a play. You ask them to draw a line made of 4 dots and join that up. And then you say to them, and what I can't convey is how fun this is and what it's like when the children think and really start to struggle and share their thoughts. So if you then say to them, I want you to draw a line that's twice as long as the 4 dots line, it gets really interesting, because what they do is they all draw a line that's 8 dots long. And if they measure it, this one is 6, this one is 14. It completely throws them how they've got it wrong, because 4 times 2, double 4 is 8. So 8 dots long. But when you start a discussion thinking, well, how long is this line? How could we describe it? Is it 4? Oh, it's 3 spaces long. Ah, 3 spaces. So how long is twice as long as 3 spaces? Or 6 spaces. 1, 2, 3, 4, 5, 6 there. Yes, that's twice as long. So if this is 1 space and this is 2 space and this is 3 space, what should we call? Oh, this is the first one. What should we call this? Oh, 0. And you can have a discussion about 0. The lesson then progresses where the children have to measure 4 lines. And you give them rulers. This is such a lovely thing to do. You give them 4 different rulers. One child has that ruler, which you can see starts at 2. One child has that ruler that starts at 4. One child has that ruler that starts at 5. And another child has that ruler that starts at 3. And when you say to them, tell me, shout out how long the line is, they'll shout 8, 9, 10, 11, 12. And they look around the room and they just think, eh? What's going on? And so what they think is they think everyone else is wrong and they're right. And eventually they start looking at the ruler and realizing that, oh, mine starts at 2. I can't use it. Mine goes 5, 6, 7, 8, 9, 8. All they're doing is reading the last value on the ruler. And it really makes them think. It really, really challenges them to think about what actually measuring is. And there's a subsequent activity where you give them some rulers that the numbers are all wrong, but on 3 of them, the gap is the same. So they have a discussion and they evaluate these. I'll share the screen again. They have a discussion and they evaluate the ruler. And eventually they realize that this ruler, this ruler, this ruler all work because it's the space that's important and we can write the numbers on. Now I've found that a very profitable activity. As a starter, to introduce 0, to introduce halfway, to introduce fractions. It's a really, really rich activity, and that's called broken rulers. I'm going to show you another activity now called jelly babies. And I would start this lesson with a story about my nephew having a party, and my 2 daughters were making jelly for him, and they made it out of 2 different flavors. And the red, strawberry and blueberry, and he loved it. And my youngest daughter, Ruby, got so carried away, she made some jelly people for him. And so the children would get these in an envelope and they have to talk about what they notice. And eventually what happens is they'll say, this one is the baby because it's got a big head. This one is the parent, mum, dad. This one is the sibling, or this is the dad, this is the mum. I tend to steer that this is the baby, this is the dad, this is the sibling. And then they put them in order and they realize that they're actually quite similar in height. But what is different is their head and their body. So you ask them to go away and come up with as many sentences they can have to describe the relations between the head and the body visually. What you then give them after this discussion, because they'll say as the head's getting bigger, the body's getting smaller, what you then give them is another envelope with some sticks in that gives a sense of proportion. So what they do is they match them up, and then the discussion gets really quite interesting. I'm just going to show you the screen of what that would look like. So what you this is, again, this can take half an hour, and how the children say it is very rich and wonderful. And some will say, well, we've got, and I'll use the right colours so it just makes it easier. They'll say, well, we've got one. There's always one. And then someone else will say, well, this one's 2, this one's 3, and this one's 5. And then another one will say, well, this is 1, this is 2, this is 4. And they start to kind of play around with the numbers. And what's interesting is this is where the interplay between ratio and fractions come in. Some will get the idea of 1 to 1. Some will get the idea of 1 to 2. Some will get the idea of 1 to 4. Some will realize, and these realizations and kind of penny dropping moments are really quite powerful, and you're listening and looking to the children. One will say, well, this is half, the head's half the body, and this is the third, and this is a fifth. What is important here is children find, who are struggling to think, ratio easier to understand than fractions. 1 to 1 or 1 to 2 is easier than 1 out of 3, a third. If they're sharing sweets, they can say, oh, 1 for you, 2 for me. So there's a kind of inbuilt sense of ratio and proportion here, and we're going from a picture to numbers to start exploring the foundations of numerical relationships, whether it's fractions or ratio. And what is really special is if you then say to the children, there's a new member of the jelly family that I'd like you to draw. And I'd like you to draw a jelly giant. And so what you get is drawings like this. Some will just draw something that's big. And what is lovely is they can walk around and say, if they have drawn a giant, you can say, oh, you've drawn a brother, you've drawn a dad, you've drawn a brother. And then some will say, I've drawn a giant. And what's interesting is this boy changed his mind. These are all from P6S1 pupils. Again, changing their mind, getting a sense of proportion, the size compared to the head. The head is smaller than the body. How much smaller? We can then come in with the appropriate mathematical response to move them on. I mean, what is lovely is you can tell how poor this child is, but he's drawn a giant. He's got it. We can then give him the words to express his thinking. I mean, I think this one's particularly lovely. This child has experimented with different. First of all, they've drawn a brother or a sister because it's 1 to 3, and they can measure with their hands and things. So that's jelly babies. And I'm just going to share with you one more, and then we should have time for anyone to ask questions we can, which is, again, I'll just show you on the paper. It's another measurement activity, but it's a way of getting children to think about decimals. And so you tell them a story about, I would always use my daughter, because my daughter has some incredible dreams. My eldest daughter, who's at St Andrews in her final year, she has some incredible dreams, and I would go to my class because a lot of these work really well in a nurture group familial type situation where you've got a teacher with say 10 students or less, and they sit around and they discuss. And I said, she had one of those dreams again. And she had a dream about a giant. She'd been to the pantomime and seen, when we can go to the pantomime, she'd been to a pantomime and seen Jack and the Beanstalk. And she had a dream about a giant who ruled his kingdom of fairies. And he was so arrogant, but he needed a new palace and he wanted to build it, but he had no rulers. So you can then talk about what we measure with. Because what's interesting is how a lot of mathematics from in ages past have come from making sense of the world. So you've got qubits, which you can work out how big Noah's Ark is using qubit, which means elbow. So I being about just over 6 foot tall, that is a cubit. So I can work out how big Noah's Ark is using a cubit. We use feet, we use hands to measure horses. So you say, okay, here's the giant's feet, here's the fairy feet. Can you go around and measure how big things are in the classroom? And I would give one child this, or a pair of children this, and a pair of children this, and not let them combine them. Because the first stage in the lesson is moving to combining the giant's feet and the fairy feet. And what you then, when they've realized that, you say, okay, I now want, and you give them a set number of things to measure in the classroom. So you say, I want you to measure this desk. And so this desk is 1, 2, oh, it's a bit longer than 3 giant's feet. So let's measure it in the fairy feet. It's 2 giant's feet and 2 fairy feet. And what you do is you say, what I say to them is, well, actually, what we need to do is we need to think about how we write down how measurements are so someone can build it. So you have this discussion about how you write 2 giant's feet and 7 fairy feet. And what's interesting is when you look at the range of responses, I haven't got time to write it down, you will get some will just do a big 2 and a little 7. Some will write 2 GF, 7 FF. Some will write 2, 7. Some will write 2.2. Because they're getting a sense of the big one comes first, because that's the giant. The giant is arrogant. He has to be present in all measurements. And so the discussion unfolds as how you would write down these measurements. And they agree that the 2 comes first, the 7 comes next. And it might be helpful if we put a point here to say when the giant stops. And the lesson ends where you say to the children, oh, there's some pixies who can help. I'll just show my camera once more. There's some pixies who can help. And the pixies have feet that are much smaller than the fairy feet. And we've got some objects that have come in that have been measured but need storing, the smallest first. And so what you say to them is, this is 1 giant's feet, 6 fairy feet, 5 pixie feet. And they've got a sense of what the number, how place values linked to size in feet terms, and you ask them to order them, and they're able to order these with the smallest coming first and the largest coming last. So I'll just go back to the presentation. I've very quickly gone through those activities. I just thought it'd be worth sharing with you 3 activities that I would always use. If I visited a school and was going to try an activity, I would do one of those, and it works because you're dealing with children who look at the world in a very different way to us, and they need to understand the measurement system. They need to understand ratio and fractions. They need to understand the decimals, and we need to help them move on from where they're at. And so if you want to know more about this and want copies of the activities, please email me. But what I'd like you to consider now and in the days going forward is, what's resonated with you about what I've said? How could this help you and your pupils? And what's it making you think more about? I mean, the premise of what I'm saying is with very, very special needs children, they need to be hands-on sensory motor activities where they're interacting with the world at an appropriate level. And one of the best of those measuring activities with the ruler happened in a special school with Key Stage 4 students, where the one boy just had an argument with another, and finally the penny dropped as the difference between the dots and the spaces. And he said, oh, it's 4 dots, but it's 3 spaces. And he used his fingers to illustrate. And so I mean, try them and let me know how they get on. There are lots of other activities we can share with you. And it's what we've been doing with several maths hubs in England. So feel free to use them, get in touch and let me know. And I think they make very good starters to topics. So you could do something and then find out how much your pupil, where your pupils are really at, and then move on. There are activities on shape and space and coordinates and number and lots of other activities. I just thought I'd pick those sample because they're quite visual. So thanks very much. I'll hang around for a little bit of time if anyone wants to ask any questions, but thank you very much and feel free to try the activities, play around with them, let me know how they get on. And if you do one of the activities, it'd be lovely to share that through Equals. So thanks very much for joining me this morning. It's been a real pleasure to share the activities with you. Thanks everyone.